Let one in real quick, y'all. All right, y'all. So 9.5 support. And like I said, this goes over properties of exponents. There's four properties we're looking at. First one is the product rule of exponents. So the product rule of exponents tells us what we do when we're multiplying variables. So if we had a to the m times a to the n, well, if you're multiplying variables, we add the exponents. So this will become a to the m plus n. So an x squared times an x to the third, we would add 2 plus 3 and get x to the fifth. Okay, so we use that a lot when we was multiplying and FOILing, okay? All right, then we got the power rule of exponents. And this is mainly when you got things inside of parentheses. So if we had, say, a to the m raised to the n exponent, so you got parentheses, and basically we're raising an exponent to an exponent. When this case happens, we multiply the exponents. So this will equal a m times n. So multiply the exponents when they're sitting behind parentheses like that, okay? All right, y'all, next. We got the quotient rule of exponents. So this is when we're dividing variables. So if I got a to the m over a to the n, well, if you had an x to the 5 over x to the 4th, we would subtract exponents and we get a to the m minus n. Okay, so if that variable matches up, we subtract exponents to simplify that. All right, y'all, and then the last one was sort of what I was showing y'all yesterday with the negative exponents. This is our negative exponent rule. Now, there's three cases of this. First case, if I got a to the negative m. So we're not allowed to write our answers with negative exponents. So basically, to make an exponent positive, you would treat the a like it's got a 1 under it, and you would flip it. So basically, you get a 1 over a. Now, when we move this a down to the bottom, it changes the sign of the exponent from negative to positive. So that's what I was talking about. When you got negative exponents after a number, it basically is a fraction in disguise. Now, the second case is what if the variable is on bottom with a negative exponent? So if the exponent is in bottom of the fraction and it's negative, I'm still going to flip it. And by flipping it, it makes the exponent positive so that this gives me a to the positive m. So basically, moving an exponent down will change its sign. Moving a next negative exponent up will change its sign. And y'all, the last thing you might see is an actual fraction, a over b to the negative m. Well, if you got a fraction raised to a negative exponent, the negative exponent affects the top and the bottom, which means we flip the fraction so that we get a b over a, and then the negative exponent becomes a positive. So basically, I'm flipping them all and making the exponents positive on those variables, okay? So these are our exponent rules. So for the support, number one, multiply and simplify. They're giving me x to the fifth times x to the negative seventh. All right, y'all, so here's the thing. We're multiplying, so we're about to use the product rule of exponents to start with. So x to the 5 times x to the 7. I would add those exponents, 5 plus negative 7. That's going to give me a negative 2. All right, but remember, we cannot leave negative exponents in the final answer. So now we got to make this exponent positive. Well, here's the case we got. This is my x to the negative 2. It tells me to flip it and make the exponent positive. So that's going to give me a 1 over x to the positive 2. Okay, so add the exponents when you're multiplying the variables, then take care of that negative exponent. All right, y'all, number 2, same thing. Multiply and simplify. Z to the negative 5th times z to the 8th times z to the 7th. All right. You're still multiplying a variable times a variable times a variable. We're still doing the product rule where we're multiplying a variable times itself. So basically, we know we're going to have a z. So y'all, let's add these exponents. Negative 5 plus 8 plus 7. And y'all, let's see, negative 5 and 8 give me 3. 3 plus that 7 gives me z to the 10th. Our exponent is positive, so we do not have to flip it. Okay, we're only doing that when we end up with the negative exponents, okay? All right, another one for multiply and simplify. All right, y'all, but look what we got here. I got a 9c to the third times 3c squared. So before I can multiply these, I got to do this exponents first. And that's going to come into the case where we got the power rule. Now, everything inside is affected by that exponent. So you would distribute the exponent to the 9. Now, remember, nobody's got exponents in here. So all these exponents in here are like a 1. If there's no exponent, we treat it like a 1. So this gives me 9, 1 times 3, so that'll give me 9 to the third. On the c, I got 1 times 3, so that'll give me c to the third. I'm going to multiply that by what I get in the second parentheses. So that's 3. 1 times 2 gives me 3 squared. And then on the c, 1 times 2 gives me c squared. All right, now y'all, now I'm going to multiply the numbers times themselves. So if you want to use the calculator, you can, or well, it's probably the easiest way, because 9 to the third, that's 9 times 9 times 9. That's 729. And then 3 squared is 3 times 3 is 9. So I got 729 times 9. That's going to give me 6,561. So y'all let me write that here. So 9 to the third equals 729. And over here, 3 squared equal 9. So those multiplied to give me the 6561. Now you got a c to the third times a c squared. So multiplying a variable times a variable, we add the exponents. So that'll give me a c to the fifth. Okay, so it's just a matter of what rule applies in what situation, okay? All right, now 4 said divide and simplify. So I got a y to the ninth over a y to the negative ninth. So we're dividing. So right here, when we divided, we said we take the top exponent and subtract the bottom exponent. So I'm going to subtract exponents. But look here, we got 9 minus negative 9. Okay, remember that's 9 minus negative 9. When the bottom's negative, you'll get 2 negatives, y'all. But remember, those 2 negatives are going to make that into a plus. So I basically, 9 minus negative 9 is 9 plus 9, which will give us a y to the 18th. So you just got to remember when you're using that quotient rule, the subtraction is always there, okay? So when that bottom number is negative, you will get a double negative going on. All right, y'all, number 5, simplify. They got 4x y to the 4th, all raised to the 2nd power. So basically, it's going back to that power rule again. You got a lot of stuff inside parentheses raised to an exponent. The 4 and the x don't have exponents, so we would treat those like ones. So we got 4 to the first squared. Well, 1 times 2 gives me 4 squared. The x has exponent 1 times 2, so that's going to give us x squared. And y'all, the y has exponent 4 times 2, so that'll give me y to the 8th. And y'all, the only step I would do now is figure out the number part, because 4 times 4 is what, 16? So you get 16 x squared y8. So you're correct at this point. You just got to finish it out because they want it simplified all the way, okay? So that is an overview of the exponent rules because they're about to play part of what we go through in 9.5 doing our properties of logarithms, okay? And then some more things we'll do in this section. We'll do some more of those where we got to rewrite those radicals as fractional exponents. So we had a few problems doing that yesterday. and then you'll see a few more today, okay? All right, y'all, so 9.5, college algebra, properties of logarithm. But remember, in the long run, logarithms is just another way to find exponents, right? So we got a few of these properties, and they almost mirror the exponent properties. So y'all, we got a product rule of logs. So I'm just going to write logs instead of logarithms, okay? So we got a product rule of logs that says if we got a log base A of m times n, well, when we use the product rule of exponents, we were multiplying variables, we added exponents. So a product of logs can be written as a sum of the logs. Log A of m plus the log A of n. Notice they got the same bases and the same logs, but we can rewrite a product as a sum. We can also rewrite a sum as a product. They go either way on these, okay? So y'all, we got a power rule of logs. So the power rule is when I got a log base A of m raised to the n. So my m now has an exponent of n. Well, the power rule of log says I multiplied the exponents. So y'all, what we do, we bring this exponent down and write it as a product times the log A of m. Because log A m would give me an exponent, and we're multiplying by the n, which is this exponent. So when it says use the power rule of logs or rewrite as a product, this is what they're talking about. They're talking about using that power rule. And if you notice, all I'm doing is bringing the exponent down to the front. Okay. All right. We got a quotient rule of logs. So that dealt with division. So if we got a log base A of m divided by n, well, what did we do when we were dividing variables? We took those exponents and subtracted it. And we always took the top exponent minus the bottom exponent. So y'all, a quotient can be written as the difference of the two logs. So you're sort of distributing the log to the top and then minus the log of the bottom. Because remember, log A of m is an exponent minus log A of n, which is an exponent. Okay? So division, subtraction, multiplication, addition. Just like our exponent rules, okay? Now also, you got to recall two more things in this section. A log base A of A equals, well, y'all, what did we say it equaled when the base of the log matches that result? What exponent would this give us every time? All right, Jackson, good job. That's going to equal 1. So we got to remember that. Also, you got to recall the other thing we seen. What if I had log A of A to the M? What did we say this equaled when the base of the log matched the base of the result raised to an exponent? Good job, y'all. Definitely, definitely. It equals M, okay? It always equals the exponent because log A of A equals 1. And see, if you're using that power rule, you bring the M down. So you got M times 1, basically, which is RM, okay? All right, y'all. So these examples are going to go through all the 3 properties at first, and then they'll start sort of intermingling the properties together, okay? So these first 2, so they usually do one problem of logs and one problem of LN to get you used to both of them. So the first 2 problems they want to express as a sum of logarithms. All right, so 1 and 2, they want me to express as a sum of logarithms. Well, here's the sum of logarithms. So that means they're going to give me a product if they want me to express it like a sum, okay? So let's see what product they're giving us. They're giving us a log base 17 of 17 times 289. Now, y'all, here's the thing. They don't want me to simplify this all the way. They just want me to express it as a sum of logarithms. So M is 17 and the 289 can be the N. That's M times N. So this equals the log base 17 of 17 plus the log base 17 of 289. So notice I distributed the log 17 to both of these factors and rewrote it as a sum. They didn't want me to go further because this one would go further, but they wanted me to just rewrite it as a sum, okay? So number 2, they did this. Ln of C times D. Now, y'all, let me say one thing on this. When you're writing answers in, this is log log. When you write it correctly, it'll make it dark and bold. This is the ln. It's not an in, it's a ln, okay? Um, we just usually write it with the little l for shorthand, okay? But that is the ln, not an I. Okay. When you write LN, it'll make it bold and dark so that you know you got it. Okay. So y'all, how about y'all try that one right there? Y'all got a chat over there. Tell me what we would get when we express the ln of C times D as a sum of logarithms. Okay, I think you're saying, okay, you're saying log looks like base E. So now you can actually do the log base E's on these if you want to. But now to make them really quick, I would just distribute the ln to both of those and make that a ln of C plus ln of D. And Jackson looks like just what you got there. Okay, so you don't have to actually change it into the log base E, but y'all, good job. You're distributing the ln and putting a plus in between it. All right, so the next two exercises say express as a product. Well, the only one where we express stuff as a product was our power rule, where we took the exponent and multiplied by the log. This is what they're talking about as express it as a product, okay? So number 3, they gave me a log base b of a y to the 14th. Now, sometimes they'll put the y 14th in parentheses, but it don't matter. I'm only going to do one thing to this thing. This power rule said take that exponent and move it down to the front, rewrite it as a product. So we're going to take the 14 and bring it down to the front so that we get 14 times log base b of a y. Now, y'all be careful to make these letters capital letters when they do, or lowercase when they do, okay? They're real picky about uppercase, lowercase on them. And then when I do the log, to get the little b, you'll see a box with a little blue box. So hit right in log, and then hit this symbol to put the b in. And then you got to arrow back up before you put in the y, okay? So I would write 14 log, hit that box, put in the b, and then arrow right, and then put in the y. So you want it to look just like they're giving us on these. Oh, y'all, let's do a tricky one here. How about ln of the 6th root of a 7? Well, we can't rewrite it as a product yet because we don't have an exponent up there. We got a radical. So we got to figure out. So y'all, I'm going to take this 7. So this is my side work. We got to convert that 6th root to 7. So let's see what y'all remember. If I bring down that 7, what exponent would I give that 7 to change it out of that radical? And y'all did a few of these kind of things last night. Oh, you're so close, Nat, but not a 1/2, because what's in that index? And I think, Jackson, I think you got it. That would be a 1/6. So remember, it's always the index that goes to the bottom of that. So y'all, this is really ln of 7 to the 1/6. So you got one move now, and that's to take this 1/6, and we're going to pull it to the front and get our project. So we get a 1/6 ln of 7. Hey, also not bad. All right, so if you think about it, I've done went through the product rule where we rewrote them as a sum, the power rule where we express things as a product. So we got that quotient rule left, and this will say express as a difference of logs. All right, so let's see. They start at what, number 5 here. So express as a difference, they're going to give me some kind of division, and it's always the top minus that bottom there, okay? All right, y'all, so 5, I got a log base t of a p over 4. All right, so distribute log base t to both of these, and it's going to be log t of p, since p's on the top, minus the bottom, which is log t of 4. Okay, so type log, then hit the subscript box, arrow right, put the p, minus, right log again, hit the subscript box, put t, arrow back up, and put in your 4. All right, so here's one y'all can do. So I'll sort of do the logs and y'all can do my LNs for me. So y'all do this one. LN of M divided by N. So y'all rewrite that as a difference of logarithms. Now remember, when they say logs, they also mean it's a difference of LNs, because that's just what we call our natural log, okay? Natural log is a log base E, but when they talk about logs, they're talking about any form of them, okay? All right, Nat, what you got up there? Ln of M, which is the top, minus the Ln of M, y'all. Good job. Ln of M minus my Ln of N. All right, so that's using the different properties. Now they're going to start mixing some stuff up on us, okay? This was just to get us a little introduction on each of these 3 major properties, okay? Now we will start having to recall this other stuff in a little bit, okay? And we will still have to be able to convert these radicals, okay? All right, y'all, so here we go. Let's turn it up just a little bit here. All right, y'all, so let me move that back up. All right, so it looks like these next 2 want me to rewrite as sums or differences of logs. Now, that could mean they're giving me a bunch of stuff being multiplied to get my sums, or a lot of stuff being divided to get my differences. Or I might have a little bit of both. So let's see. For number 7, they're giving us log base C of parentheses x squared y to the 7th and z. So y'all, one question. Let me see what y'all think. When I rewrite this stuff, will I rewrite this as sums or will I rewrite this as differences? So y'all putting pluses in between those, or are we going to put minuses? Nat, good job. Those are sums. Because you got a product here. So we got to use our product rule. Distribute log C to all 3 factors. So y'all watch this. I get a log C of x squared plus my log C of y to the 7th plus my log C of z. Now, y'all, let me tell you one more thing. there is one more thing I got to do to this because there's another thing it has to have done to get it simplified 100%. And y'all, let me remind y'all, we got a power rule out there. So if we got exponents after our logs like this, we got to rewrite each of these sections as a product of the exponents. So we got to bring the 2 down to the front on the first log so that you get a 2 log base c of x plus the second log. We got to bring that 7 down to the front and make that a 7 times the log c of y. And then there's not an exponent up here other than 1. So we don't have to do nothing to that. So we get plus a log c of z. So y'all, when we're doing this kind of stuff, they do want us to take this further and bring down our exponents, okay? Oh, y'all, so number 8, same thing, but look what I got here. I got a log base b. Now I got a big fraction here. On top, I got a P3 Q5. On bottom, I got an M3 B8. All right, so P3 Q5 over M3 B8. Okay, so here's the thing. I got a little bit of products going on these. So the easiest thing to do to a problem like this, you're going to distribute the log b to all 4 of these factors here. But y'all, here's the thing. If the factors are on top, they're rewritten with addition. Factors from the bottom get subtracted. So you're still doing the quotient rule, but the stuff on top, so watch this. We got our log b, we distribute to the P3, plus we got a log base b of q to the 5th. So since these 2 factors came from the top of the quotient, they got to be positive. Now we're getting to the bottom. Everything else has to be subtracted. So you would subtract log base b of m to the 3rd minus log base b of b to the 8th. So I will say the thing about logarithms and stuff, you don't really get to get rid of a lot of stuff. So they're just a lot of simplifying is all you're doing, okay? So what could make so can I do anything now? I do got to do something, y'all. So what would we do next? Well, Jackson, we really don't have like terms because remember the P's, Q's, M's, and B's, none of those are matching up. But I want y'all to think about this number 7, what we had to do. Y'all look at this. I got exponents everywhere right here. So yeah, we got to put all the exponents in front. Now, 3 of these, I will do that. But y'all, this one, you got a log base b of b to the 8th. What does this right here equal? It equals 8. Good job. So when I bring down to 8, it's basically log b of b is a 1. So this whole thing don't equal nothing but an 8. So let's rewrite the exponents on the first three and then make that an 8. So we're going to get a 3 log b of p plus 5 log b of q minus 3 log b m minus 8. So y'all, you got to get used to this, because if you put 8 log b of b, although it's the right answer, it ain't simplified enough, okay? All right, y'all, so remember, things on top of the fractions come out positive. If they're on bottom, that's all that minus stuff. They're negative, okay? All right, y'all, ln of 7 over 6x to the 6y. All right, y'all, so I want y'all to realize you got one factor on top, you got 3 factors on the bottom. So let's see what we got here. So I'm going to start with the ln of 7, that, and then you got, so you were really, really close, but that 6 needs to have its own factor. So we would do minus ln of 6 minus ln of x to the 6, and then minus ln of my y. Okay, so treat the 6 and the x to the 6 as 2 different factors. All right, y'all, guess what? I got one more move. I've only got one exponent to bring down, but that's going to cause me to rewrite everything. So I got an ln of 7 minus ln of 6 minus 6 ln of x minus ln of y. Okay, y'all, so just remember, there is actually 3 variables in that bottom. All right, y'all, so looks like we can at least get one more in before we do our break. So y'all, this is a log of a square root of a c to the 5th times d. All righty, so what we got to do, get rid of that radical. So on my side, let's play with that. So my first step, this C5D, I would put that in parentheses first. And then what exponent would this square root turn into? The square root would turn into a 1/2. So remember, if there's not a number in the little notch here, it's automatically a 1/2, okay? Now, to simplify this, we're going to multiply the exponents of both of these times 1/2, because that's my power rule. So I get C, 5 times 1/2 is 5/2. And on the D, remember that's a 1 there since there's no exponent. And 1 times 1/2 is 1/2. So y'all, this becomes a log of basically C to the 5/2, D to the 1/2. Now remember, technically this is probably going to be in parentheses at the moment because it's all affected by that log. So the first move, this stuff's being multiplied in here. We're going to rewrite it as a sum log C to the 5/2 plus log D to the 1/2. Hey, y'all, let me ask y'all a question. These here logs right here, they don't have a base by them. What would be the base when there's no base shown on these two logs? See if y'all remember that. 10, good job. So those are actually the common logs, and they would have a base 10. Good job. Oh, y'all, guess what? Oh, we're not done yet. We got one more move. And that's to bring all of our exponents down to the front. So it looks like I'm going to get a 5/2 log C. Plus over here, we bring down that 1/2 log D. All right, y'all. So nothing else we can do to that. Final answer. All right, y'all. So let's see. Let's see how many is all together in this. So 17. So we're pretty good on it. So now, so let's take our break. I'm showing like 10:49. So let's come back at about 11 o'clock. At 11 o'clock, we'll finish out 9.5. Okay. So y'all, I will see y'all in about 10 minutes. All right, everybody, I am showing 11 o'clock. So we're going to continue. There's one more where we had to write it as sums or differences, and then they sort of changed the directions, okay? So let me get us recording. And we pick up with number 11. All right, y'all, so here's the big one for number 11. Log base A. Now this is a big radical, and it's a fourth root. On top, we got a M16, N20. On bottom, A9, B5. Okay. So I'm going to work on rewriting it without that radical first, okay? So this side work here, and when you get quicker at them, you'll be able to do this quicker than what we're doing here. But that's a fourth root, M16, N20 over A9, B5. So the radical affects everything in here. So you would start out by putting all that inside parentheses. And raising them to a fractional exponent. Well, since that's the fourth root, our exponent would be a 1/4. All right, so now what you would do for your last step, distribute the 1/4 to every part that's inside those parentheses. So for the M, we got 16 times 4, which is 4. On the N, we got 20 times 1/4, which is 5. On bottom, for the A, we got 9 times 1/4, which is 9/4. And on the N, we got 5 times 1/4, which is 5/4. All right, so now that's what we want up here. We want our log A, and then M4, N5 on top, over A to the 9/4, and then B to the 5/4. Okay, y'all, so that's what takes time on this one, is getting it converted out of that radical and then distributing that exponent, okay? So now, remember, I'm going to rewrite it as sums and differences. Factors on top are added, factors on bottom will be subtracted. Distribute the log A to all 4 of these. So I got a log base A, M to the 4th, plus a log base A of N to the 5th. So those 2 were on top, like I said, they're positive. Then we subtract log base A of A to the 9/4 minus log base A of B to the 5/4. All right, so tops added, bottoms subtracted. So y'all, now I'm going to bring this 4 down to the front on the first one. I'll bring the 5 down to the front there. That one, since I got a log base A of A to the 9/4, this is just going to equal the exponent 9/4. And then at the end, I'll have minus 5/4 log A of B. So 3 of those are bringing exponents down, and 1, I'm just going to evaluate and put the 9/4, okay? So my final answer would be 4 log a m plus 5 log a n minus 9/4 minus 5/4 log a of b. So y'all, it is really, really important that you realize when the base of the log matches the base of the result raised to an exponent, it always equals the exponent, okay? All right, y'all. So that was, that's like 5 of them where we had to rewrite it as sums or differences. And you also had to utilize that power rule and bring them exponents down to the front, okay? So starting at 12, what they want us to do, they're going to give us 2 or more logarithms, and we got to write them as a single logarithm. So we're going the other way. We're going to start with this stuff and end up with that kind of stuff, okay? So these examples will say express as a single logarithm. All right, y'all. So number 12, I got log base C of 5 plus log base C of 21. So in order for us to get a sum of logs, we started with a product of logs. So if you start with a sum of logs, you're going to rewrite them as a product. So you're going to bring out that log base C, and then your product will be 5 times 21. Now, when you're writing them as a single log, MATLAB does want us to multiply that out when we can. So that gives me what, a log base C of 105. Okay, so when you're going into a single log, if there is places to multiply, they definitely want us to do that, okay? All right, so let's see what we got here. A log of 100,000 minus a log of 10,000. All right, so they're being subtracted. So when we ended up with a difference like this, we started with a quotient that looked like a fraction. So this is the positive part, so it's going to go on top, and this part being subtracted will go to the bottom. So bring out the log. So y'all, my top will be the 100,000, and the bottom will be the 10,000. All right, so one more step to simplify that. 100,000 divided by 10,000, that's going to give us a log of 10. So now that would be the first answer on this one. So it's written as a single log, but then it says this simplifies to blank. So y'all, what does a log of 10 simplify to? Good job, y'all. That is definitely a 1 on that one. Because remember, that's a log base 10 to a result of 10. So anytime that matched up, your answer was definitely a 1 for that, okay? All right, y'all. So let me get this paper fixed. Okay, so looks like what, number 14. Oh, watch this one, y'all. This is probably one of the trickier questions on this homework. I got 1/3 log C of x plus 4 log C of y minus 5 log C of x. So here's the thing. We're going in reverse. Okay? So when I wrote them as sums and differences of logarithms, the very last step we always did was bring all these exponents down to the front. Well, y'all, guess what? If I'm going the other way, my first step is to take all these exponents and bring them back up. Because you remember, you're undoing the stuff you did to get to this. So I'm going to bring the exponents up first. So I get a log C of x to the 1/3. All right. Plus, this one will give me a log C of y to the 4th. Minus, this one will give me a log C of x to the 5th. Okay, so I've rewritten them with the exponents up there now. So now before, when I got stuff that was positive, it was on top of a fraction. When I got stuff that was negative, it was on the bottom of the fraction. So I'm going to rewrite it as a single log and positive factors on top, the stuff being subtracted to the bottom. So bring out that log C. All right, so there's my fraction. On top, I got the x to the 1/3 times the y to the 4th. The only factor being subtracted is the bottom, which will be the x to the 5th. Now, y'all, here's the thing on this one. Although we're almost done, what's stopping me is I got an x on top and an x on bottom. We got to try to simplify these x's. So if you got an x to the 1/3 over an x to the 5th, we got to take care of that, right? So here on the side, I got an x to the 1/3 on top and an x to the 5th on bottom. Y'all, to simplify that, what am I going to do with these exponents? And that was in that support lesson, remember? Remember, when we're dividing variables, we subtract exponents, right? So that'll be, good job, x to the 1/3 minus 5. Well, y'all, what is 1/3 minus 5? And we do got calculators that'll do that. So you can punch in 1/3 minus 5. It's going to give you a negative decimal, but turn that back into a fraction. You should get a negative 14/3. Or you can make this 5 have the same denominator by multiplying top and bottom by 3. So you got 1 minus 15, which is negative 14, over your 3, okay? All right, now, but remember, that 14/3 has to be positive. So we would put that under a 1 and get x to the 14/3. Can't keep the exponent negative, so we had to do that negative exponent rule. If it's on top, we bring it to the bottom. So that means it's positive on the bottom. So my final answer will be a log base C. Now, the only thing on top will be the y4, and the bottom will be the x to the 14/3. Okay, so that's one's my trickiest one. But here's the thing. You see how this 5 exponent is bigger than that 1/3? the answer for the variable always stays where the exponent was bigger at, okay? Which would have been the bottom in that case. Hey, y'all, so that is sort of trickier because you always end up with that x over x's, and one of them's usually a fraction like mine, so. All righty, let's see what we got here. ln x to the sixth minus 3 ln cubed root of x squared. So on the side, let's play with that for a second. We got a 3 ln cubed root of x squared. All right, so first of all, I'm going to turn this square root into a fraction. So bring down your 3 in your ln. All righty, y'all, so here's the thing. You got your x. Now, this radical would make a 1/3, but when your variable has an exponent by it, that becomes the top number. So this will be an x squared over the index, which is a 3. Okay, so that goes back to this property. If you got the nth root of a to the m, that equals a to the m divided by n. It's always the index of the radical on the bottom. Now, the reason we were writing ones a while ago was because our variables didn't have exponents by them. But if the variable does have an exponent, that will become your top number. All right, so simplifying this now, well, the 6 is already brought up over here, so we got to bring this 3 up over here. So I get a ln x. Now, when you bring the 3 up, it gets multiplied by the 2/3. And 3 times 2/3 gives me an exponent of a 2. All right, y'all, so let's put that in. I got my ln x to the 6. All right, ln x to the 6 minus ln x squared. On that, good job. I think you got this one knocked out. Because since they're being subtracted, I'm going to write them as a quotient. So ln, the positive factor goes to the top. The factor being subtracted goes to the bottom. And y'all look at that. When you have x's divided by x's, you subtract exponents. And 6 minus 2 gives me an x to the 4th. Okay, so, whoo, y'all, you got to get used to this radical stuff, okay? Switching them radicals into them fractional exponents. And we haven't done that a whole lot this year, so that's why we sort of break out the support and do the exponent rules. All righty, so y'all, we got 2 more of these to roll through, so let's see what number 16 has. Y'all, you got an ln in parentheses x squared plus 12x plus 27 minus ln parentheses x plus 9. So on this number 16, what we want to do is rewrite subtraction as a quotient. So bring out that ln On top will be the positive factor, which is the x squared plus 12x plus 27 all over, well, the factor being subtracted is an x plus 9. So y'all, here's another place that we're going to use factoring, and it's why we really ride factoring so hard. You got to be able to factor the top of this, because to simplify this, we got to cancel out factors that match up. Now, this x plus 9 is a one factor, okay? You can't cancel the x's out by themselves or the 9s. You got to factor that whole x plus 9 out if it's going to simplify. So let's bring down our LN. The top is the only one on this one that can factor. The bottom is going to be an x plus 9 no matter what. So y'all, let me see how good y'all are at factoring. Y'all have a x squared plus 12x plus 27. What's the top factor into? So now you got the right answer. So what did your top factor into? X plus 3, x plus 9, perfect. Because beyond that last sign's positive, both factors are positive like the middle number. Factors of 27 that get 12 are 9 and 3. And so what happens, this x plus 9 will now factor with this factor, x plus 9. So y'all, we get our final answer, ln of x plus 3. And you got to keep the parentheses like Nat did on this one because the ln affects this whole thing, okay? So, that's your trick on 16. Now, notice, if it was going to simplify, we knew that one of these factors on top had to be a 9 because the only way to cancel x plus 9 is if one of these was a x plus 9, okay? All right, also, my last one is similar to number 16, but instead of using LNs, they're using logs. So I got a log of x squared plus 9x plus 8 minus a log of x squared minus 1. All right, so nothing I can do but rewrite this. So the positive on top, subtraction on the bottom. So I got my log. So y'all on top, x squared plus 9x plus 8 over the x squared minus 1. You know, I'm going to give you a hint. Both of these are going to factor. I will say this, the bottom is what we call perfect squares, and the bottom will factor into a conjugate pair down here, okay? But how about my top? What can we factor x squared plus 9x plus 8 into? So I got an x plus 1, x plus 8, perfect. So last one's positive. Both of my factors were positive like the middle, and factors of 8 that equal 9 were 8 and 1. And good job. The bottom was the difference of perfect squares. So x squared is an x and an x, and then the square root of 1 is a 1 and a negative 1. So y'all see what's happening now, right? This x plus 1 cancels with that x plus 1. So my final answer. Now, since I still got a fraction left, I don't have to put parentheses because I got an x plus 8 over x minus 1. So when you got a fraction left, You don't have to put parentheses because it's understood that there's like imaginary parentheses around that top and bottom, okay? All righty, y'all. So that is a look at our properties of logarithms. Now, we'll say this, tomorrow is Friday. We're going to be solving equations. So we're going to solve equations that are exponential. And remember, that was the stuff like this. We'll solve exponential, and then we'll solve our logarithmic, okay? So a couple ways we solve the exponential, and then there's a couple ways we solve these logarithmic. But you want to get used to being able to take two logs and writing them as a single logarithm, okay? Because a big part of doing these equations is being able to rewrite two logs as one or vice versa. All right, y'all. So let's see. We're only doing one section today, the 9.5 and the 9.5 support. Because I want y'all to learn these rules real good, these properties, so that tomorrow when we hit them equations, they'll be a breeze for us, okay?